Hello, in this video, this is 4.4 of section 1.2, and this is modeling problems, solving problems that can be modeled by quadratic equations. So much like the other modeling problems in section 1, chapter 1, section 1, you have to read the problems sometimes 2 or 3 times to kind of get an idea of what they're talking about. Drawing a visual diagram, it can help you to do that. And then once you come up with the equation, you've got the model, and then it's pretty much downhill from there. You just have to solve the equation and then answer the question. There isn't an easy road every time, and you can't show students all the techniques, all the situations that you might have. So word problems are somewhat unique in themselves. They have common themes, but there can always be a little twist on any type of a situation that you might encounter that is not, it's unique to a different problem that you might have seen prior to that. Okay, so let's begin. All right, so this is an example we're going to look at. We're going to construct a box. Okay, from each corner of a square piece of sheet metal. Now, what is a square piece of sheet metal? That square means it's the same on both sides. You're going to remove a square of 6 centimeters and then turn the edges up to form an open box. If the box is to hold 486 cubic centimeters, what should the dimensions of the piece of sheet metal be? All right, let's look at this. So we're going to use this figure as a guide. We have labeled by X the length of the side of the square piece of sheet metal. The box should have a height of 6 centimeters, and its square base should measure X by 12 on each side. Like, why is that? Well, let's look at the sheet metal. Let's look at the picture of the sheet metal here. You took 6-inch piece square corners off of each side. So the blue part of this T shape represents the sheet metal that's left. The yellow corners is what's removed from the corners. So you're going to remove and discard this, and then you're going to fold up the edges to make it look like this box. So now do you see it? So you got to go from 2-dimensional to 3-dimensional. So you're going to take those 6-inch corners, remove it, and then fold up the edges, and the part of the T that's right smack in the middle of this T is actually the bottom of the box. And then you're going to fold up the edges, the cross pieces, and it goes up to the top, and it will have a box that has an open top on it. So now, when you do that, there's X inches straight across. But remember, you took off 12 inches off of, 6 inches off one side and 6 inches off the other side. So that's why it's X minus 12 as what's left over from both sides of the bottom. So the base is actually a square. It's X minus 12 both sides. Now, why is the height 6 centimeters? Do you see why? Because when you fold up the edges, you remember you cut those 6-inch corner pieces off, and when you fold them up, that aligns with the height. Now, how do you find volume? Volume is length times width times height. So its length is X minus 12, the height is X minus 12, so the width is X minus 12, and the length, and the height is 6. So you multiply those together, and so here's our model. Since the volume of this box is 486 cubic centimeters, we have 6 times X minus 12 times X minus 12, which is X minus 12 squared, equals 486. Now let's go back to that previous box again. So volume is 6 times X minus 12 times X minus 12. So that's the volume. And they tell me in the problem the volume is to be 486. So as you can tell, pictures are very helpful sometimes. And then it becomes 6 times X minus 12 squared equals 486. There's your modeling equation. It's up to you to solve it. Now this is where it's usually downhill from now. So what we're going to do is we're going to divide both sides by 6. And then we get X minus 12 squared equals 81. And so X minus 12 equals plus or minus 9 when you take the square root of both sides using the square root property. So isolating the X, we'll add 12 to both sides. We'll add 12 plus 9, and that's 21. And then 12 minus 9 is 3. All righty? Now, here's where a lot of people make a mistake. They think, well, okay, 21 and 3. Now, just circle those. They don't know what to do with them, so they'll just circle them and move on. And you'll get a lot of the points, but you won't get them all. You might get 4/5 or 3/5 of the points at this point, but you won't get them all because you haven't answered the question. Well, what do? Well, you discard the x equals 3. Why you discard the 3? Is an answer, isn't it? Well, why is that? And then we conclude that the sheet metal is 21 centimeters by 21 centimeters. Now, what was x representing? Do you remember what x was representing? What was x in the first place? Let's go back. X was the width of this sheet metal. That's what it was at the very beginning. That's what x is. So if x is 3, if it's 3 centimeters by 3 centimeters, there's no way you can take off 6 centimeters, can you? If it's 3 centimeters by 3 centimeters sheet metal, there's no way you can take 6 centimeters off of each corner. So yeah, at the very beginning, you know x has got to be greater than 12. Because if you take 6 off of one side and take 6 off the other side, then it's got to have any volume whatsoever. It has to be bigger than 12. So right at the very beginning, I knew x had to be greater than 12. So 3 is not greater than 12. So we discard that answer. So let's go back. And remember, x was 21 or 3, so we throw the 3 away. And then 21 is what we keep. So that's what you say. So we conclude that the sheet metal should be 21 centimeters by 21 centimeters. Okay? Now, I know this is only going to be one problem that you're going to see, but I wanted to show you one application. There are others. The author creates some in that slide, so you can watch his author videos. That will be our next step that you'll be looking at. If you're doing your homework and you're like, I didn't see one like that Gary did. I didn't see one that the author did. I just still don't know how to do this one. No, don't wait till the last minute to ask me this, but let me know and say, well, this is the problem that I'm doing on the homework section 1.2.25, whatever that problem is, and then say, I'm having problems with this one. Can you show me how to do a problem like this one? And I'll be glad to do it. I can do a video of like this much like this one, do a specific problem like you're asking me to do, and then upload it to the student request videos for all to see, not just for you to see, but for everyone to see this one. Because when one person asks in these type of courses, then I open up for everybody to see it. And I think it's fair for everybody all the way around. So, all right. So if you have any questions, let me know, and you have a good day.